Okay, let's look at the next strategy is to identify a sub-goal. So sometimes the question might be more complex, and to answer it, we need to kind of look at the sorts of approach it with, sorts of have more granular step approach, or have kind of the smaller goals in our mind to be able to answer the final question. This is a good example. Arrange the numbers 1 through 9 into a square subdivided into 9 smaller squares, like the one shown in the figure below, so that the sum of every row, column, and main diagonal is the same. The result is a magic square. Okay. So this is the type of magic square when you want to use the numbers from 1 to 9 and you want to make sure that the sum in every row, column, and diagonal is the same, right? Okay, so probably the first goal in your mind would be, okay, what is this common sum that all the rows, columns, and diagonals are supposed to have, right? So let me see, sub goal, or I'm gonna call it just goal 1 to answer the question, what is the common sum? Okay. Well, we're using numbers from 1 to 9, so we can add them all up together, and then I know that if I think of it, I'm splitting them into 3 sums of 3 numbers, right? Because look at this picture. If I were to put all the numbers in there and I highlighted it in green, then of course we're gonna have 3. Those 9 numbers will form 3 sums of equal value, right? So once I figured out what is the total sum of all the numbers combined, so sum from 1 to 9, heck, I can do that, right? I just have to, using Gauss's approach, I have to rearrange them in the decreasing order, so twice the sum is pretty much 10, 9 times, because we have 9 terms here, and so that's 9 times 10 divided by 2, which is 45, so that all the numbers combined add up to be 45. But then if you divide this 45 into 3 equal sums, right, then because we have 3 rows, or you can think 3 columns, but basically 3 equal sums, then that's going to be 15, right? So the answer is, to that first kind of, my sub goal is 15. Okay, so now I know that basically those 3 numbers will have to add up to 15. So in every row, column, and diagonal, the sum of numbers is 15. So then the goal 2, I probably would think, okay, what are the possible combinations of those 3 numbers that come up to be 15? So all possible sums of 3 numbers from 1 to 9 adding up to 15, right? I should be able to list now how many possibilities do I have. Well, let's look at, that's also good to know. I'm going to list exactly what possible sums I have, but it's good to know how many. So notice, if I look at those sums here on the pictures, I have 1, 2, 3, because 3 rows, right? Then I have 4, 5, 6, because 3 columns, and then 7 and 8, because 2 diagonals. So according to the picture, there should be 8 possibilities. Okay, so I have 8 possible sums like that. So then let's see. I first will focus on a fixed one, and then I usually start with the highest. So 1, 9. well, then that establishes the last one to be 5, because remember the sum has to be 15. Okay, I keep fixing 1 until I list all possibilities with 1 in front, in fact with 1 as one of the numbers. So 1, now instead of 9 I'm gonna go down, so now it's 8. So of course that forces the last one to be 6. Okay, then 1, 7, right, that's 8, 7, well that's not possible because that would have to, cannot repeat. Then 1, 6, which is 7, then that would have to be 8. Again, that's the same as 1 before. And 1, 5, but then it's 9, is the same as I already have. And 1, 4 cannot be, because then the third number would have to be 10, and I only can use up to 9. So notice I actually, those first two exhaust all possibilities of sums involving 1. Okay, so then I'm going to move to 2. So what if one of the numbers were 2? Then again, and I'm going to count the second to be 9. So 2 plus 9, that's 11, which forces the last number to be 4. Then 2, 8, which is 10. Then the next number is 5. And then 2, 7, that's 9. So the next number is 7. Okay, 6. And then 2, I'm going down, right? First 9, then 8, then 7, the second number. So now I'm going to go 6, but then that will make the last number 7, which is the same as 2, 7, 6, right? The same three numbers involved. 2, 5, and 8 already also was there. 2, 8, 5, right? So that's I have. 2, 4, 9, okay. 2, 4, 9, okay, I already have. That's the sum here, involving 2, 9, and 4. And 2, 3 cannot be, because then the last number would have to be 10. Okay, so then I know actually those are all possible sums involving 2. So then I move to 3. 3, 9. That's 12, so then the next number would have to be 3. Not allowed. Okay, so that's not it. 3, 8, 11. And 4. Okay, that's so far good. Now 3, 7, that's 10. So last number would have to be 5. 3, 7, 5. Okay, it wasn't before, so I'm good. Then 3, 6, that's 9. And then to add up to 15, the next number would have to be 6, but they cannot repeat, right? 3, 5, 7, well, that's already there. That's the one before. 3, 4, 8, well, it's this one here, right? So also I cannot use. 3, 3, I cannot. And 3, 2 also I cannot have, because the last would have to be 10. Okay, so that exhausts all with 3. So then I'm going with 4, right? And notice, by the way, I already know that I need 8. There are 8 possible sums, and I already have 7. So really, there's one more, right? So now sums involving 4. So 4, 9, 2. Well, that one I have right above it. Okay. So instead of 9, let's try out 4. Sorry, 8. I go one down, right? 4, 8, 3, but 4, 8, 3 is here, right? It's the same numbers, so that's not this. 4, 7, that's 11, so the next number would have to be 4. Well, that's not also allowed, because numbers cannot repeat. So 4, 6, 5. I believe that I didn't have it so far, which means that's it. I don't have to even look any farther, because I know there are 8 possible sums and I already have them. So that tells me that I'm done. Okay, so I listed all, and now I have to put those possible sums appropriately in my this magic square. But the goal 3 would be well, identify the number that needs to be placed in the characteristic points in this magic square, because I noticed that whatever number is here right in the middle will show up into 1, 2, 3, 4 sums. So I'm gonna look at what number so center number appears in 4 sums. Okay, so what it can be, that's kind of my question. Okay, so I look at those possible sums I listed. Is there a number that shows up 4 times in 4 different sums? And of course, some of us might see it. I'm sometimes like, if you like me and sometimes you can stare at something and still don't see it, then of course you just look, okay, 1 appears in 2 sums, and you can go step by step. 2, I see it only twice, right? 3, and so on. But though some of you probably see that 5 shows up here, 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 and here. So 4 times, and that's the only number that appears in 4 sums. Okay, so that means that in the center, I can put, that's the only number I can put in, is 5. Now let's look at the corner numbers. They're characteristic as well, because they appear in the 3 sums, 1, 2, and then diagonal 3, right? So which numbers can go in the corners? Corner numbers appear in 3 sums. So what they can be? We can probably phrase it better, but okay, so can I identify a number that shows up in 3 sums? Let's see. 1, no. 2, yes, right? It appears in 3 sums, so for sure 2. Now what about 3? 3 only appears in 2. What about 4? 4, yes, 4, 4, and 4. So that's gonna be 2, 4. Then what about 5? 5, well, 5 already we identify. So what about 6? 6, yes, 6, 6, and 6. So 6 can be a corner, put in the corner. And then 7. Okay, 7, 7. No, only twice. 8. Yes. 8, 8, 8. 3 times. So 8. Okay, so I have my numbers. There are 4 corners, right? So I don't have to look for more. So then I will put in the corners. So 2, 4, 6, and 8. So notice like even numbers. So, and I'm gonna, it doesn't matter the order. 2, 4, 6, 8. I'm going clockwise. So then, of course, since I know the sum must be 15, I can fill in the gaps, because 2 and actually, sorry, it cannot be. What did I do? It cannot be like that, because the sum has to be 15. So I put 2 and 4 in the corner, but then 2 plus 5 is 7. So that number has to be 8. It cannot be 6. I just put there 6. But it, remember, has to add to 15. And then 5 plus 4, that's 9. And then plus 6. So those numbers, I took it back. I couldn't just place them randomly, because if I place 2 and 4 that way, then it forced my hand how to place 6 and 8. So that diagonally they add up to 15. Okay, but now of course I can also fill in the gaps. 2 plus 4, that's 6. So to add up to 15, that needs to be 9. 9 plus 5 is 14, so that has to be 1. And 2 plus 6 is 8, so this has to be 7. And 4 plus 8 is 12, or 7 plus 5 is 12. So that needs to be 3. And notice all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 are there, and all the sums are 15 as needed. Okay? Okay, so let's look at the next strategy, make a diagram. So I said, okay, we can make a, earlier should have probably organized it this way. We had to make a table, but another way to sometimes help ourselves is to draw some kind of picture of a diagram. So here we have a question. Bill and Jim ran a 50-meter race 3 times. The speed of the runners did not vary. Okay, so in all 3 races, Jim run at the same speed, and so did Bill, right? So they always run at the same speed. In the first race, Jim was at the 45-meter mark when Bill crossed the finish line. In the second race, Jim started 5 meters ahead of Bill, who lined up at the starting line, who won. In the third race, Jim started at the starting line and Bill started 5 meters behind. Who won? Okay, so we're gonna kind of make diagrams to visualize the situation, and really then it will turn out to be a simple one. It's a 50-meter race, right? So we have, and I'm gonna kind of draw 2 scenarios. Jim, okay, there's a starting point, right? 0, and then there is 50-meter mark. Okay. So in the first race, Jim was at 45-meter mark when Bill crossed the finish line. So actually, I should have read it carefully. I'm gonna make separate line for Jim. Jim went to 45-meter mark. So let's say here's 45 meter. While at the same time, Bill did 50 meters. So blue will be Jim and green will be Bill. So I also like using colors. So diagrams with colors, even better. Okay. So that's kind of visualization of the first race, right? So race 2. In the second race, Jim started 5 meters ahead of Bill, okay, who lined up at the starting line. Who won? Okay. So what do we do? Well, if we have, again, Bill did like before, he lined up at the starting line and ran the race, right? So he ran 50 meters, still the same speed, right? At the moment the Bill finished, what happened with Jim, right? Right now that we know that when Bill does 50 meters, Jim runs only 45 meters, right? Which means that now that Jim started 5 meters ahead of Bill, okay, if he started now 5 meters ahead of Bill, then, right, they both finished the race or arrived at the finish line at the same time, right? Who won? Okay, which to me the question who won is a kind of not exactly correctly stated, because it wasn't quite a fair race, but okay, they both, let's say they both no winner, right? They finish at the same time. Right, because within the same time as Bill did 50 meters, Jim did 45, but since Jim was 5 meters ahead, he kind of arrived at the 50-meter finish mark at the same time. Okay, so then race 3. So that's part A, and here's part B, race 3. In the third race, Jim started at the starting line, and Bill started 5 meters behind. Who won? Okay, so this time Jim is at the starting point, right? And he ran, say this is, I'm gonna in black, I'm gonna mark here, that's 50 meters, but we know that Jim does 45 meters. Okay, so he would finish here, not that color, 45 here. So that's Jim. But now what happened is that Bill now started 5 meters behind. So that's kind of the, right, Jim. And remember, remember that it looks like within the same time, right, they are at the 45 meter mark. Okay, but the question is who won the race. So what happens, right, what I'm trying to say is that we know that within the same time, Jim runs 45 meters as Bill 50 meters, right? If Bill was 5 meters behind, they met, they were exact, they crossed the 45 meter mark at the same time, right, of the race. Because for Bill, that was really 50 meters he ran, and for Jim, 45, because he started at this starting line. Okay, but of course, since Bill runs faster, right, he will win. He will finish earlier, right? Since Bill is faster, he will cross the finish line first. So he will win the race. Or cross the finish line, I should maybe state it as in the past, right? So, okay, so that means the question, Jim started, okay, let me do crossed. The finish line first, so he won the race. Okay, because question was who won. Okay, well, Bill won, even though he was 5 meters behind. At they crossed the 45 meter mark at the same time, but of course then Bill runs faster, so he finished first. Okay, and an elevator stopped at the middle floor of a building. If they moved up 4 floors, stopped, moved down 6 floors, stopped, and then moved up 10 floors and stopped, the elevator was now 3 floors from the top floor. How many floors does the building have? Okay. And again, when you read a question like that, it's hard in your head to kind of really answer it. But when you start drawing a diagram of some sorts, it might become really easy. So I will start with like okay, middle floor, that's the elevator starts middle floor. So for me, my middle floor, I'm gonna mark how elevator is going, right, in a line. There's my middle floor. I'm gonna call it 0 for that, so it's easier to count. Okay, so an elevator stopped at the middle floor of the building. So that's kind of step 1. I'm gonna mark it by 1 dot. I sometimes do it for myself. That's kind of a progression of moves, right? Then it moved up 4 floors. Okay, 1, 2, 3, 4. Okay, so that's the next progression, 2 dots, or you can write in the parentheses step 2. And stopped. Then moved down 6 floors and stopped. So when you go down 6 floors, I'm gonna get to say -2, right? Again, 0 is this is the middle here, middle floor. Okay, so that's my third kind of progression. So moved down 6 floors and stopped. Then moved up 10 floors. So now go next 10 floors. So I'm here, right, at -2, kind of. So I go 2 up. So I'm in the middle. And then still 8 up because I'm going 10 floors up, right? So 4, 5, 6, 7, 8. Okay, so then I'm gonna be here. That's my next series of stops. So I'm gonna put 4 dots just for myself to see the progression, right? And elevator is now 3 floors from the top floor. Well, then I know that the top floor is 11th floor, right? 11 top. Okay, so that means that I have 11 floors above the middle floor, so then also 11 floors below the middle floor and plus the middle floor. So how much do I have? Well, let's write it down. 11 floors above the middle plus 11 floors below the middle floor plus 1 plus the middle floor. So together we have 23 floors, right? So again, if this was 0th, then I ended up having 11 above it, 11 below it, right? You can visualize that would be -11, kind of more or less, trying to. So I have 11 below, 11 above the middle and the middle. So together 23 floors. Okay. So there it is. The diagram helped a lot. Without the diagram, that might be complicated. With the diagram, it's not too bad. So, okay, another strategy, which for more advanced math courses, we tend to tell students not to do it, guess, trial and error kind of approach, or guess and check, where, because, and besides very often more advanced math courses have problems stated that way than guess and check, or trial and error, another way of saying, is really not a kind of good strategy. It takes too much time, and very often if the answer involves fractions, it might be difficult to come up with it by just doing that. But of course, for less advanced courses, sometimes it makes sense to do that. So let's look at the example here. A group of students is building a sailboat. The students have 48 square feet of material to make a sail. They designed the sail in the shape of a right triangle, as shown below. Find the length of the base and the height. If they have 48 square feet of material to make the sail, then it means that the area of this triangle should be 48 square feet. Let's establish this one first, okay? Now, and you might be thinking, oh, I don't remember what the area of the triangle is. To be honest with you, well, right triangle, you don't have to really remember the formula, because you can visualize that the right triangle is half of the area of the rectangle, right? And we know that the area of the rectangle is, width times height, right? Basically the product of the two lengths, the two sides we have. And in our case, right triangle is half of it, right? So the area of the right triangle, or this triangle, will be, I'm gonna just in general write, if you have a triangle, this is A, this is, usually we write it H. Then again, you can visualize rectangle, so the area of this triangle would be 1/2 A times H, right? Because A times H would be the area of the entire rectangle, and half of it gives you that triangle. All right, so that's this. So we don't really need to know the formula. So I'm going to do try and error, or guess and check. I'm going to figure out X, which then will tell me what the other side has to be, 1.5 times that. And then I'm going to estimate the area, and we're doing square feet, okay, and in feet there, so that then, well, by try and error, I'll come up with what I need. Okay, so I want to do 1.5, so I'm going to take even length. So 6, so 1.5 is 6 plus 3, so 9, and that's all in feet, right? 6 feet, 9 feet, so then the area is half of 6 times 9. 6 times 9 is 54, so half of it is 27 square feet. Well, not what I'm looking for. I'm looking for 48 square feet, which means I need to increase, right? I'm going to go to the next even number. So 8, right? 1.5 of that is, half of 8 is 4. So 8 plus 4 gives me 12. That's 1.5. And then 8 times 12 is 96. Half of that is 48, which is exactly, so that's the area of the triangle, and that's what I want to have, right? Which means that length of the base should be 8 feet and the height 12 feet. Okay, and again we figure it out by trial and error. Of course, to that example above, we could have used equation that would involve like solving quadratic equations, so maybe you know, easier what we did, guess and check. But let's look at problems that we might want to use equation. A bicycle is on sale for $139.93. This is 30% off the regular price, okay? You need to find the regular price, okay? So basically before the discount, what was the original price, okay? So we know that the price we see is, what, 70% of the original price, because the discount was 30%, right? So if the original price was decreased by 30%, now it's the new price is 70% of the regular or original price. So if I call X, what I'm looking for is to be regular price, then I know 70% of X is gonna be the price that I see, right, after the discount, okay, because we decreased it by 30%, which is, and remember, you switch percentage by moving 2 decimal places to the left, dividing by 100. So 70 divided by 100. In other words, saying you move 2 decimal places to the left. It's 0.70 or 0.7x is this. And then you can use a calculator. You have to divide both sides by 0.7 or 0.70, the same thing. And X will then end up being 199.9. So that was the original price, right? Or the regular price. Price is $199.9. Okay. Okay, so let's look at another one that we might want to solve using equation. And then notice that this one, of course, the previous strategy of guess and check doesn't apply here because we're dealing with not what nice even like integer numbers. We're going to deal with fractions, decimals, and guessing the answers is basically almost impossible. A compass and a ruler together cost $4. The compass costs 90 cents more than the ruler. How much does the compass cost? So we basically have two things, a compass and a ruler, right? And we want to figure out the cost of the compass. So we usually tend to call the x what we're trying to find, right? So x is the price for the compass. Okay, so then we know that the compass costs 90 cents more than the ruler, right? Okay, so the ruler costs 90 cents less, right, than the compass. Another saying, just rephrasing it. Compass costs more, ruler less, right? So x minus 90 cents, right, which is x minus 0.90 if we're gonna do it dollars. That's gonna be the ruler's price. Okay, so then if x is the price for the compass, then x minus 0.9 or 0.90, because we want to have price in dollars, is the cost of the ruler. But together they cost $4. So if I add the cost of the compass to the cost of the ruler, it's together $4. That's why I needed to convert into dollars, right? Because I had that they're combined, the cost was $4. Okay, so of course here the parentheses are not necessary, so I can get rid of them, and then I have 2x minus 0.9 equals to 4. 0.9 is the same thing. Of course, you're gonna add 0.9 to both sides, so 2x will be 4.9, and then you're gonna divide by 2 both sides, so x gonna be 2.45. So the compass costs $2.45. Okay. Okay, and the next kind of strategy we're going to do is apply logic, although that's we try to apply logic to every problem, even the ones before, but sometimes there's no computations, no diagrams, nothing that can help, just the logic itself. So 3 closed boxes, A, B, and C, of fruit arrive as a gift from a friend. Each box is mislabeled. How could you choose only one fruit from one box to decide how the boxes should be labeled, right? So you know that every box is mislabeled. So now you just can choose one box and pick one fruit from this box, and that should allow you to sort of, relabel correctly the boxes, right? Okay. So let's think. I'm pausing here so we all can think about it, but then basically what I see is the following. If I draw, or if I pick one fruit from the box apples, well, then what will happen? Well, I know that this box might be oranges and apples. So I know it's mislabeled, but basically maybe instead of apples, there should be oranges and apples. So if I draw a fruit from this and I'm gonna get oranges, right? Then it's not gonna allow me to determine, okay, so doesn't mean that in this box I should have just oranges or oranges and apples, right? So basically that's might be too risky to draw, fruit from this box, because if I pull orange, I'm still not gonna know, right? It could be that this will be oranges and apples or just oranges. Same from this one. If I choose this box and take one out and that happens to be an apple, then all I know is that's basically either just apples or oranges and apples, which honestly I knew even without picking a fruit from that box, right? So that doesn't is not a good strategy. But let's think what happens if I were to choose this box, oranges and apples. And so I know it's mislabeled, so it's either just oranges or just apples, right? So if I pull the fruit from here and it turns out to be oranges, right, then I know it's really that it should be labeled oranges, and from there hopefully I should be able to determine the list. So it looks to me this way, that we have to pick one fruit from box B, the one labeled oranges and apples, mislabeled, right? So first, let's summarize. We have to pick one fruit from box B. That one I know for sure. And let's think of the possibilities, what can occur. Okay, we pulled out, and let's say let's start with orange, doesn't matter, an orange from box B, right? From the middle box. Okay, so if we pull the orange, then that means that I know that this is just an orange then, right? A box containing just oranges. Okay, if that containing just oranges, okay. So then let's look at this one. I know it's not apples. It cannot be oranges only, because that is taken by, I know, already in box B. So this has to be apples and oranges. Right, because if it's not apples, and I know it's not apples, I know it's mislabeled. And I also already know it cannot be just oranges, because that's in the box B. Then it has to be apples and oranges, okay? So then this obviously will have to be just apples. Okay. But what about case 2? So what if we pulled out an apple from box B? I know it's not oranges and apples, so if I pull out apple, that means it's just only apples there, right? Okay, if there are only apples, then here when I look at I know it's not oranges, so of course possibilities would be either just apples or oranges and apples. But I already know it's not apples because that's in box B, so it's gonna have to be oranges and apples. Okay, so this one has to be oranges. Okay. So notice that, yes, I am correct. I even analyzed possible scenarios. If I pull out one fruit from box B, then in either possible scenarios, I'll be able to correctly label all the boxes correctly, right? Regardless whether I pull out orange or apple, of course, then they will be labeled differently, but in either scenario, I'll be able to determine what's in each box. Okay. And the final one, maybe the easiest one, the 14 digits of a credit card are written in the boxes shown. If the sum of any 3 consecutive digits is 20, what is the value of A? Okay, so this is kind of logic, but also sometimes, you know, just basically to come up to your answer, you have to sort of look at everything in between. So in this particular, if I know the sum of any 3 consecutive digits is 20, then I look here. That's 11, so I'm missing 9. And then, well, so then if I look at those consecutive 3, 7 plus 9, that's 16. So that's going to have to be 4. But then I look 7 plus 4, that's 11, so this will have to be 9. But then 4 plus 9, that's 13, so to sum up to 20, that has to be 7. So then 9 plus 7 is 16, So this has to be 4, so that those 3 add up to 20. 7 plus 4 is 11, so that has to be 9. And then 4 plus 9 is 13, so that has to be 7. 9 plus 7 is 16, so that has to be 4. 7 plus 4 is 11, so this one has to be 9. 9 plus 7 is 16, so this one has to be 4. And then 7 plus 4 is 7 plus 4 is 11, so this has to be 9. So basically A equals to 9. Okay, and that was, I think, one of the easiest problems. And that's all for this lecture.